And today we're going to talk, the first part of the day, we're going to talk about wire EDM. Now, the wire EDM product has been renamed to GibbsCAM Wire EDM, powered by OptiCam. Andreas, thanks for the input on that document. It looks really nice. They built a really nice document that shows that. So today we're going to go through it in a little bit of detail. I plan on having a wire EDM only class in May. That will be just wire EDM and it'll be very detailed, very deep. So we're putting that together. So keep that in mind. It'll be about middle of May. And so this is going to be a big overview, kind of get you guys started on it again. There have been some changes. There are some things that we know that are a small problem, but we'll get those fixed if we can soon. We're working on that. So, okay. Good. So let's get started. So I'm going to go in here, open up a file. And I put all these in millimeters so that it makes it real easy. I'll get all the files to you guys. So it works out really well. And this is where we're going to start. This has become one of my favorite parts because it shows off a lot of things that we can do with wire EDM. And it makes it pretty simple. Let me switch back a few things here because some of these things people are getting very confused on. So I want to be sure that everyone understands what we have to do to get this going, okay? All right, so this is where we would start. What you need to remember is that in the document control, the only way to launch EDM is to make sure that you have selected this MDD. Okay, there's a special MDD just for wire EDM. When you select it, it launches EDM. If it's not selected, you just get normal Gibbs, yeah, like this. It's no problem. But if you select the vertical wire EDM, it launches this dialog. Launches this dialog on the side here with all the functions. Okay. You'll also get this new pull down up here, this OptiCam. I don't normally use any of these settings. I typically do everything from the side here, but you can, if you like, create new operations, do feature recognition, simulation, but most of these commands, I should say all of them, are on the right mouse click. The only one you might use here is some basic setting stuff where you can set millimeters or inches. Doesn't really matter to you. The languages, so it does have its own set of languages. So they do cover most of them, which is pretty good. If you didn't know, this is a German company, and they are pretty decent people. They've been very helpful, very responsive to our needs. So, all right, you can set some colors up, which we'll talk about a little bit later. Some start hole stuff. There's lots of details, lots and lots of details inside of this. So you can set up, depending on what the customers are cutting, you can set up different ways you approach, different distances, positions, all sorts of crazy stuff. You have all these different choices, okay? Some of these I've had to change just because if someone wants to start in a different location or do something different. It does do automatic feature recognition, which is very slick. There are a few places where it's very handy, and we'll talk a little bit about those, but you can set the feature recognition stuff to do whatever you want it to do, whatever you want to pick up on. These are our choices. You can have it pick, sides to cut on. You can group features together. One nice thing about this, if you have a set of features that are grouped together, By using automatic feature recognition, it will group them automatically, and you can ungroup them or you can group stuff together. It's pretty slick, actually, the way it works. That's a lot what this menu does here. There's some posting things, but again, we'll talk about that through the menu itself. Okay, so before we start, right now we're at this, what we call program standard, which means there is no technology. This has been the biggest hurdle in this whole process with this product is the technologies. If you know anything about wire EDM, each machine has a set of parameters or technologies, as they call them, that drive the machine for power settings, flushing, do we cut the wire, is the wire loaded? I mean, there's all sorts of different things that can happen. So this product sets up based on per machine and per machine type. So it's not like Gibbs where we can select a Haas, whatever, VF4, and we can put 20 different parts on it. When we set up a Mitsubishi machine, an FA or an MB or whatever it might be, that's where all the settings go. They will not transfer to an FA. They won't transfer it somewhere else. They are set for that specific machine. So you need to keep that in mind. So every machine that you set up can have its own set of parameters, and it will have its own set of parameters, and that's it. There's no getting around that, okay? And it makes perfect sense to do that. All right, so let's talk about, this is the most confusing part, so we're going to go through this. And that is actually setting the technology. And I'm going to take some pain here, and we're going to go through this because I'm recording this so that you can go back and look at it. I get this question every day for the last 3 weeks, okay? How do I do this? So I'm going to go through this. It will be recorded so you can go back and review it. And if you have a question about the technology, there are some videos already created I can send you guys. It's not a big deal. They were sent to us by the OptiCam people, or actually it's CamTech people, to do this for you. So this is how this will go. First thing you want to do is select the machine type that you like. Okay, so you come down here, and these are all the machine types that we support at the moment. I'm sure there's some more, but these are the major ones. So let's talk about let's do Mitsubishi. So Mitsubishi, this is the post processor we're going to use. Now, you as a dealer will get all the post processors. So don't call and ask for a post processor because you already have it. Okay, it's like a global, it's almost like a master post. Okay, so you already have them. There's no question about it. What you don't have is the technology. And that's where everything kind of comes apart. Well, technologies are for cost or for purchase items, so you have to buy the technologies from CamTech. So you say load the post processor, and you'll always get this message. Okay, and it is what it says. It's a warning, and basically the warning says you don't have any technology set up. That's all it means. That's it. That's all it's telling you. I've been trying to have them turn this off, but they say it's a good thing. It's okay, so fine. So once we do, okay, so now we've loaded the post processor, it just kind of defaults. And these are the choices you're going to have for each machine. Now, some machines have a lot more than others. In this case, the MITS has many different options for machines, and they all are a little bit different, okay? So I'm going to load up this one because I've been, let's see, let's do a different one here. Now let's do this. So I'm going to load up this MV4800, and then I'm going to load its post processor so that it knows, okay? So it seems like a lot of work up front, and it is a little bit of work up front, but at the end of the day, once you set it, it's done, okay? So the next thing I'm going to do here is go to the post processor options, and you should only have to do this one time. And under the post processor options, we have a general tab. And luckily for all of you, it automatically defaults to metric. So if you have somebody over there that's using inches, which I really doubt, you won't have any issues here. It automatically defaults. But there's some things that you can do here to affect the output. So in the old wire EDM or in Gibbs, where you have to actually physically go into the post, here you can affect some things yourself without having to go into the post and change it, okay? Line numbers, for example, okay? Some machines have a start hole drill built into the machine. You can create a file, will automatically create a file for that. You can, in fact, add header information. I was working on this yesterday. It's kind of weird, and I have some questions, but you can add some header information, dates, times, part numbers, those kinds of things. You can add, you can build a text file that allows you to do those kinds of things if you need something very special. And the same at the footer or at the end of the code if you want to do that. And it just basically puts in literal statements. So if you wanted to put some information in there, you can write a text file, point to it, and it will put those that text into the post automatically. You don't have to worry about it. We'll already put them in. Based on the machine, you can set up how many decimal places. You can have it open up in an editor if you want. You can have it create a setup sheet, which we'll do. We'll turn that on. And you can add or not have the comments put in. Again, some customers love the comments, some don't. So instead of having to go and edit the post to turn them off, you can just shut them off here. So the end user does have some control over what he's doing. If we go to the NC output, here again, you can set up different profiles for different ways you want to cut stuff. I'm not exactly sure why you would want to do it, but hey, you can. And you add things. You can change the file extension, how you want to output, different ways you want to thread the wire. Do you want to fill the tank? And these just output, like this here will output this M122, which closes the door, fills the tank, and does some other things for you. Okay? Some people may not like to do that. Maybe they have some other thing that they like to do. Maybe they have things built into the machine. Again, this page allows us to affect the output without having to adjust the post. The next thing we need to do is add the technology. I should have picked a different one because I already have this one. I'll go through it anyway. It doesn't matter. So I'm going to go down here, and this is where all the magic happens, right here. And this is where the technology stuff gets loaded. So you click on Manage Technology, and you get another page. That's a message that says I was adding a bunch of header information. I didn't add it, and that's okay. I'm going to go ahead and remove this just because, so I can go through the whole process. All right, so what will happen is it will look like this, and you will get, for your customer, you will get a post, I believe, one post, and technologies, I believe. And then you have to install them. And this is how you install them. You go down here and you say import to tables. And you find where it's going to be. And in my case, I have them set up, I have a bunch of different ones. And I'm just going to pick this one here. I'll pick the MV4800. Okay, because that's what we selected. So that's what you're going to get. They're going to match. We're going to open that. It's going to import the data. Perfect. So now you have it. So the next thing I need to do is activate it. So I'm going to come down here and activate. What I like to do is refresh the list because sometimes it appears, sometimes it doesn't. So always refresh is good. I pick what I just loaded. Now I want to pick the header. And the header is MV, so it knows what to pick in the database. We're going to put in a new set of tables. So these are the wire diameters that we'll be using. At the very bottom, you see these green buttons as they were. You need to select them. You need to commit and then set the technology. Now, once you do that, the technology's been loaded. And that's about all you have to do here. These other things we're not going to get into, something completely different, so we're not going to get into that. One thing in Wire EDM, the green check mark always is okay, or like do it, for example, okay? So you always want to click it when you do something. If you haven't done it right, it'll tell you. It'll say, hey, no, this doesn't work. Once you've done all that, you notice that we have the database. It's perfect. And that's all we need to do here. We can close this, and we can close this, and now we can go on and we can machine our part. I know that was a bit long, but at the end of the day, that's the part that's really critical here. And without that, you can post, but it kind of gives you some weird messages and things will come out, but you won't get the right technology, the e-packs and those kinds of things. So just be aware of that. So we'll go through this menu here. Here you can set the origin if you like. You can set it wherever you like. Okay. Pick an edge, vertex. I'm not going to do that. We're just going to keep it here. We do have some strategies. Here we're going to use a program strategy, so there isn't anything yet because we don't really have anything done. And then here we have the technology, and this is where everything gets a little bit shaky. It's been a challenge. When we did this a year ago, believe it or not, this was completely different. We've changed it 100%. They've been working on it really hard for the last few months, and it actually works. For you all in Europe there, the millimeter stuff always worked. For us here in America, when the inch conversion stuff really didn't work, it was really a struggle for us. But it all works now. They made some changes, very cool. So we're very happy. So what you would do here is there's a couple of things. You can use something here called the machine technology, and that is what we just loaded. So if we click on this table comes up, and it could be different for different machines. So for this particular machine, this is what it looks like. For Fanuc, looks completely different. For Fanuc, for MITS FA, it's completely different. Looks totally different than this. So it depends on the machine and the technology database that you load, how this is going to look. And I don't know what all these things do. I can guess at what some of them do. But the end user, I've installed one for customer, and when we brought this up, he goes, oh, it looks just like the machine. So the end user knows what they look like. So if you're not sure, don't panic. The end users actually understand what all these will do. So here you can pick, the wire type, what type of material we're going to use, the height of the block, is it a die, how many cuts you want to take. All right, we can do that. And you can see down here, these are the number of cuts and finishes. Okay, so let's do 3 cuts. If we double click on this, we're going to get we're going to get a crash. Okay, this is a problem. Sorry, guys. You're going to watch me do this because this is a problem. There's no other way out of it. Nothing like doing stuff live. And it only seems to do that on a select number of technologies. Doesn't do it on everything. Let's see if we can make it crash again. See, this one's a little bit. Oh, this is the only one here. Yeah, no, it's all goofed up. Sorry about this. Give me a second. Let's change it here. Should have it still loaded. Okay. Sorry about that. I just discovered that yesterday. So anyway, you would pick your technologies. I'm not going to do it again because I'm not going to have it crash again. I discovered this yesterday. There still are some things that go on here and there, but you should be able to select, and it will come up with a confirmation page. You set the confirmation page, and it sets the technology for you. We'll try that after a while. I'm not going to do that again. The other thing you can do is the cuts, what we call the cuts editor. And in the cuts editor, now with the technologies, what we all need to understand is they do have some, they don't have all. And for the older machines, they may not have a database. Now, you can ask the customer to give you that database, and they will put it in for you, or you can put in your own values. So you can actually come in here in this cuts editor, and you can put in whatever offsets you want to put in there. Okay. Now I'm not a millimeter guy, so these are probably not even close, but you know, you can do something weird like this. Let's do this. Doesn't matter as long as you have something in there. You have to set these offsets. Now you can switch these off if you want. All I'm showing you here is that you can change these things. You can put in feed rates, different wire diameters, power settings. There's a number of things here that you can do for this particular machine. You can then save this technology by saying save it. Number of cuts, what's the height, and then you just give it a name. We'll call it and then we can save that. And you'll notice here in the offsets, it actually changed. And that wasn't doing that before. That was a problem for us. So now in the user technologies, instead of the machine technologies, in the user technologies, if we select this, we should get this pull down here, and there should be, and again, it didn't save it, so there you go. So this is a bug on this machine. So what should have happened is it should have populated this dialog, and they should be in this pull down. So I'll have to get on that right when we're off the call. But in any case, it does set the offsets, and that's really what you're looking for here. So again, this has been an issue, and now I see that there are a couple other ones here that we'll need to address right away. For the workpiece, you can do a couple of different things. You can just use the box around there. You can actually specify a solid. So if you have a solid part, and I'll show you that in a little bit, or you can use an STL file for the stock. It's pretty cool. All right, so at this point, what we want to do is create a toolpath. What I'd like to do is we'll just go to the operation, we'll right mouse click on it, and you can create new operations, delete them. There's all sorts of different things you can do underneath. This is where the simulation is. I'm going to do a manual feature recognition here. Let's do this. Let's get rid of this one here. I'm going to do manual. Manual feature recognition allows us to pick the faces manually. I don't know how else to say it. So you can go in here and I can just pick that face, and there's the toolpath. Done. Okay? That's simple. Right? There's no magic here. It's that simple. I pick the face. There you go. It's done. You always want to say finish the feature. Okay, always. What I like to do, and there's a couple of different things you can do here. You can, and this is a question I get all the time too. Hey, I want to have it start in a specific place. So what I tell people to switch on is use selected face for lead on. So which face do you want this thing to lead on? I want it to lead on that face. And that's where it goes. It's that simple. Okay, there's no magic here. I'm not doing anything weird. I'm not holding down any keys. I haven't prepared anything. It's just that simple. And people are really liking the fact that it's that simple. You can just pick a face or pick an area and off you go. Okay? Really, really nice stuff. So in this case, I pick here, finish the feature, it's done. This is now done. I can post this right away if I wanted to do that. So if you want to see the output here at the bottom, give it a name. Yep, it already has a name. It comes up here. You double click it, and there is the output. And for Mitch, this actually is pretty close. There's a couple of weird things in here that you may not like. There's a couple of things I don't like, but for the most part, in fact, after we get off this call, I'm going to work with a customer to try to get this squared away so they can actually use the product. So this is actually the code we're going to use. So it's just that simple, guys. There's no really crazy stuff that you have to do. Now, what I said earlier is if you want to impact the output, we can go back here to the post-processor options. And for example, let's add this command in here, this lift tank, because they need it. Okay. We can go up here to the general tab and let's open it up in an editor. Let's create a setup sheet, and that's good enough. Now, from here, I'm just going to repost it. So it automatically opens it up. So I don't have to do anything. I have to set all kind of weird parameters. It opened it up. It actually added the M122. So it added it. So I didn't have to do that. Created a setup sheet for me. So there's the code, and here's the setup sheet. It's HTML. So it creates a setup sheet for me automatically with some parameters about what we've done here. Okay. So it's pretty cool. Any questions so far? Everybody's still out there, right? I hope. Hello, everybody out there still?
Hey, Steve. Yeah.
Okay.
All right. All right. You're good.
All right.
Keep going. Keep going.
Just making sure.
Just extremely fascinated.
Yeah. Okay. So that's that. So that's an easy, quick way to create the tool paths. Let's delete this, and let's do an automatic feature recognition on this part. So we're going to do automatic feature recognition. We have some choices here. We can do internal and external. If you have multiple bodies, you can have it do multiple operations for each body. Like each solid will be a little different. You can do punch-only features, or we can do 2D features. 2D wireframe stuff, it was an afterthought, and it sort of works, but it's getting there. You can use it, and I can show it to you. Here's where you can also make some changes if you want, some start hole settings and some feature recognition settings. But for now, we're just going to go ahead and we're just going to say, just go off and give me the tool paths. So just like that, it created the tool paths. So it created this. And again, one of the downsides is if you don't create a start hole, it just figures out its own place to start and it starts. One of the downsides, and that's based on the parameters that we set here in the start hole settings. And then here's a repeat group. So basically, instead of programming each one separately, it creates a group of like features. Now we could switch that off and say, hey, don't do anything that's a cylinder, and it won't do those, which is pretty cool as well. Now, the automatic feature recognition works really good. If you're doing some simple stuff like this, boom, it's done. I find that most people are liking the manual stuff because they have a bit more control over what they're doing. But the feature recognition and demo looks brilliant. You can go, boom, it's done. It's over with. So this is really nice. All right, so far so good. One of the really nice things about feature recognition is that you can use different things, and I really like this. You can use colors, okay? So I really like the fact that I can pick and choose what I want to machine. And in some cases, let's say, for example, I don't know, this comes from your engineering group, and they say, okay, I only want you to cut the green areas. That's all I want you to do. Don't cut anything but the green. All this other stuff is good. Well, I could go in manually and I could pick each one of those spaces. But what if there were, in fact, 100 of them? Okay, or too many, or that's too complicated. Pick something. I don't really care. So now what I can do is I can go to the automatic feature recognition, and we have a color list. Okay, and in the color list we have some colors, and we've built those colors in a list. So I can go and manage the list, look at the color list, and you can create different colors that you want to machine. Okay, so in this case, I just want to machine those green areas. That's it. Okay, so I'll say okay to that because I'm in automatic. I'll say okay to that. And look at that. I get like features, and it only machines those colors. So very cool. I think this is really, really cool stuff. You can do this, and people are like, wow, maybe I just want to do this. It's much easier. If you have a complex shape, which I'll show you a little bit later, that has a bunch of features in it, you don't want to pick everything like a punch or something like that. What you want to be able to do is pick it by color, and you saw how easy that was. And this is the thing that we need to keep in mind, that some of this stuff is very easy to do. So even though it's like, oh yeah, that's kind of all fluff, it's not. It's very handy, especially if you have different things that you want to do. Okay, so far so good. All right, so that's color stuff. I really like that, by the way. Now, one of the other questions you're going to get a lot of is about start holes. What do I do for a start hole? Well, in the EDM, you need to create a surface cylinder. That's how it works. That's their technology, not ours. It wasn't our decision, it's theirs. So you actually physically have to create a surface cylinder. Now, because we're all friends here, I'm going to tell you that there is a bug that needs to get fixed. And they're working on it right now. And that is that sometimes when I create a toolpath in Wire EDM and I generate a start hole, it doesn't recognize the start hole right away. That is a known problem, okay? And they're very aware of it, and hopefully it gets fixed. I was told maybe this week we would get another build and it would be fixed. But for now, if you want to mess around with it, for now, you have to go back out of Gib. You have to go out of EDM and then come back in. Okay, that's what you have to do. So sorry about that, but that is something that they're working at the moment. So that's why I backed out of EDM. So what I want to do is create a start hole. Okay, so how am I going to do that? Well, first of all, I'm going to create a piece of geometry that I want the start hole to be, and I'm doing this for a specific reason. Because, as you all know, I am the macro god or king, or I love doing the macros.
Absolutely.
I have created a macro that creates a surface cylinder automatically. So you pick the circle, and I have 3 different ones that I created. I initially created one where you pick a point, a little dialog comes up, and you can type in all the values, right? It knows where it is by the point, but hey, what radius do you want? And it creates it. And then somebody said, oh, it'd be nice if you just could pick a circle. Okay, so I picked a circle, and that's how this one came about. And then there was, oh, it would be nice if you could have both. So I actually have 3 different ones. This one seems to be the most popular, and I'll send that to you. Okay, so basically the way it works is it looks at the solid, it finds the height of the solid, and it creates the correct size cylinder. Okay, so really simple stuff. But basically that's what it does. And if you haven't noticed by now, everything is plus and Z, okay? Because in EDM, the table is 0 and we work above the table. It's not like milling, we're going to mill below. Everything is above. So that's why it always goes one direction. It won't go any other way. All right, so I'll go back to EDM. It should work now. All right, so let's say I wanted to do another toolpath. So let's go in here. We'll do a manual. I'm going to select that face. That's where I want it to start. I finish the feature. It moves into the start location. So it could be here, it could be here, it could be anywhere. Doesn't matter. That's it. Done. The key here is to make sure that you finish the feature, and then you'll see it move. A lot of people won't do that, and they'll go, oh, it didn't work. Well, it does work, but you have to click on finish the feature. And when you do that, that becomes then the start point. So very cool, very easy way to make stuff happen. Okay, and I'll provide you with that macro, because that's going to be a pretty good part of this to make sure that you get the things that you need. Okay, so far so good? All right. Let's look at a couple of different other things. Let's look at a 4-axis part really quick. Actually, I should have looked at the other one. That is wrong. So here we have, sorry, as you can see, I was working on this. So here we have a real 4-axis part. Now, right now, the WireEDM product likes solids, and it makes perfect sense. What we don't provide at the moment is a way to sync all the lines up, because if you're using a solid model, it's already synced, because they're basically just ruled surfaces, and that's what they have to be. Now, we can do some weird things where you have a variable wall. It will find it, and it will work pretty good. But for the most part, guys who are doing 4-axis, what I find is these are ruled. Okay, they're straight up and down. And in order to create a ruled surface, they have to be synced anyway. Otherwise, it's twisted. That's laws of modeling. Okay, so in this case, very simple. Now, we could just, and again, you guys can do whatever you like. I have a habit of using manual. I've gotten in that habit because I like to select the things that I like to select. So this is truly a 4-axis part, right? I'm not going to do anything weird here. We're going to select that face, finish the feature, done. That's it, done. Everything is synced. All the sync lines are correct. It's very nice. There really is no reason to change that. We can go right in and we can do a simulation. And you can speed it up, and there you go. And you can see it from the side here. It's making all the moves. It's very nice. Actually gives you the taper, where it's going. So let's rewind this guy. I'll slow it down. So you can actually see the moves here. So it's showing you the moves automatically, the angle that you're cutting at, some of the technologies, the offset. So it does give you some information about what's happening as it's cutting, which is actually kind of slick. You know, gives the end user some idea of what's really going on. Okay. And that's just one way to simulate. You can do a solid simulation. And we'll just do this, and it will do a solid simulation as well. Goes around, kind of shows you what it's cutting out. And we'll continue on. And then it says you want to remove the slug. Which side are you removing? Because it does matter. We want to remove the red. And then we want to continue. And then it's going to make a couple of skim cuts. Okay. So again, 4-axis, no problem. As long as the model can be done, as long as you can see it in 4-axis in the solid, it's a no-brainer. It's too easy.
Steve, I got a question.
Sure.
If you created the start hole and then in the manual mode you selected a phase. If you would select another phase, would the software still regard the start hole?
Yes. Yes.
So
Go ahead. Go ahead.
And if you got more than one shape you want to machine, and you would create a start hole for each of them, the software would automatically realize which start hole would go to which phase or to which form.
Yes. Yeah, you're ahead of me.
Oh, sorry.
No.
Thank you. Thanks.
Yeah. No. Yeah, it does recognize multiple start holes. Absolutely. So the point I wanted to make here is that if you have a 4-axis shape and it's a solid, it's really simple. Pick the faces or a group of faces or the whole model. We could have done this with automatic as well. And you have what you have. Okay? Pretty simple.
Just for the sake of it, if you had created more than one start hole, what would happen? Would it work, or would you get like an error message? If you get only one shape but more than one start hole.
Okay. If I have one shape and more than one, wait a minute, I have a part here. Oh, I guess I don't have it in millimeters. I guess I need to make sure I put it into
Oh, okay.
I need to put it in millimeters. Sorry. I thought I had this one done. So here's a part that has 2 start holes, one shape. I'll delete the toolpath so you can see it. Okay. One shape, 2 start positions. For whatever reason, I've already people have asked me to do crazy things. All right. So just something like this. I'll do automatic here. And it's done. So we have a start position here and a start position here. It just picks up on it. It's very cool. Does that answer the question?
Yeah, sure. Thank you very much.
And you can add stuff, and there's a small bug if you add a feature. And what I mean by if I would add a radius here, sticking out, and I had to redo it, there's a little bit of a problem there that we're working on. But that's a rarity. Usually I would go back and build the thing and start over. It makes no sense in some cases. So does that help you? Good. All right, let's see. Here's another example, just to show you that. And this should answer your next question, right? What if I had multiple shapes with multiple start holes?
I can see, yes.
Okay. So in this case, see, and in this case here, it's you can go by and pick each one. Yeah, okay, that's not an ideal situation. So I would run automatic feature recognition on this. And it's going to take a second, but this is the way I would handle it, because this is going to come up and you're going to go, well, gee whiz, that's a lot of work to pick each one of these. And it is. But the problem here, it's not a problem, but the issue here is that I don't want to do these holes on the outside, right? I don't want to do that or this or that. I don't want to wire those. They're bolt holes. So what I can do is I can select these and then just delete them out of the list. So now they're not there. I mean, that's a simple way to do it. I would have gone in and set it for cylinders. Say don't do the cylinders, but I have cylinders here. So I have to be aware of, what's going on and what's happening. And then these are all done for me. Pretty cool, huh? It's easy.
Absolutely.
And then for this here now, there's a couple of things we can do. So let's look at a couple of things that we didn't look at. So now under the operation, once we've created an operation, under this operation, there are a lot of parameters we can set. We can set the description, the file name, part numbers. Where do you want the wire to start? Right now, what we've had up till now is it's always starting at the origin, but I want to start at the first feature. So this would be the first feature closest to the origin, and we can look at where it is, and that's where the wire will start. So it's not traveling all the way over there. It's going to wrap it over there and then do that. You can set explicit coordinate systems where you want the wires to start from. You can set the origins, how you want them. Again, these are for the machine, so it's different. You don't see G54. This is something completely different for this particular machine. Fixed heights on the blocks. I mean, all these different things you can do. Okay, so that's just one place. What you'll also notice is that we have this load and save. Okay, now this is a little bit interesting because basically what load and save does here is it saves the defaults. So if I save this right now, and then I go in and make a bunch of changes, and then I go, oh, gee whiz, I don't know what I had, I would just load, and what would happen is any default setting that I had set previously would be loaded. So anything that was saved previous would be reloaded, which is really kind of nice. I struggled with this going, gee whiz, I want to load some settings, and they only load what was previously saved, and it works. So if a customer is doing, because there's so many choices here, sometimes you may get lost and you want to set it back. This allows you to do that, which is kind of nice. Again, underneath the operation. So these 1, 2, 3, 4 things at the top, origin, strategy, these are global. These become per operation now. So per operation, I can set a bunch of parameters. I can set reset the origin. I can reset the strategies if I wanted to do that. So here I can set routing, for example, routing optimization. Let's look at it. There's the routing optimization. So it's smart enough that it follows this optimization. It looks pretty good. And you can change it. You can set your own positions. Now here's something a little bit different. I mean, it's pretty cool. Okay, you can set a start and end position. It will change all of this. So on a part like this, it works really, really well. You can have it ignore certain things. I mean, there's a lot of choices here. And again, you can save this and it will be the default settings always for the customer. So even if he makes a change, you can go back to it. You can, in fact, set the technology different here. So if you don't like the technology that we set globally, you can change it because you may have multiple operations. And maybe multiple operations do something different. You can change a work piece. Okay. Now we get to the actual toolpath itself. So if I open up this, now I have another set of choices that I have. This thing is very powerful. And then if I open this up, we have some strategies, which we'll probably just use the ones that we've decided, or we can change them again. Then you have a choice here for each segment. What do you want to do? You want to add some moves? You want to delete some moves? How do you want to handle some things? Do you want to change the technology for this? Maybe in this case, this particular cut is a one cut kind of thing. We don't care about skimming it, how close it is, any of those kinds of things. You can change the technology. You can change the lead in, lead outs. Okay. You can change the start hole dimensions, endpoints. How do you want it to lead in and lead off for this particular one? You can add events, right? You can add a taper, right? You want to add a taper. That won't change the model, it'll just change the toolpath. You can add a taper. You can add different events. Hey, I want to add an M code there. I want to add a G code there. I want to insert some comment there. All these things can happen here. Okay. And it's very cool. Different types of corner relief. You have all the choices. How do you want the corner reliefs? And again, these become very specific to very specific types of parts you're trying to cut. On a part like this, I would group some of these together and do some of these things like if this was a punch block. I would not do a square corner here. I would do some kind of a circular corner, because otherwise it's gonna crack. Okay, I know that because I built dies for 16 years, so I know that this will crack here. So I would do some kind of undercuts. But the point is that we're giving you all the options. Pockets, maybe that one wants to be a pocket. Okay, and you can pocket it, and it just does it, right? I didn't even do anything, it just takes care of it. By switching it on, it just does it. Or you can do a variable offset pocket, which is kind of weird, but, you know, pocketing. Okay. So to show you that this gets really deep and you can set all these parameters. And again, if you go through here and you set some stuff, you know, some events, and you do this, and you know, you can set all the events up. It's pretty cool. Okay. So it's, again, very, very deep. Questions about this?
Steve, it's Shai. Hi. Can you show me the order of the cutting? It's not depends on the list on the left. It depends on the path.
Yes,
like
depends on the path.
Order. Can you set it manually or just automatic? Do you have option?
No, you can set it manually. You can actually move these around. You can grab them and drag them around. We were doing this yesterday.
But does it define the order, the cutting order also, or not?
Yes. Yes.
Yes.
Yes.
Okay, great.
Okay.
My second question is what about the cutting order? If you want to rough everything to make the first cut for all these features and then make the finish.
Yeah, that's here in the strategy. So here you can change, you know, what do you want to cut first? You want to do all the pockets first, or do you want to ignore the order? Do you want to do tapers first? Do you want to do internal, external? Do you want to do all the rough cuts together first? All of it's here in the strategy. You just have to switch it on. So it's all there.
Okay, great.
Okay.
And how do you set a taper for the shape? For example, I want 3 millimeter on the top to be a vertical, and then a taper of the 3 degrees.
Right. Here I would pick what I want to set, and I would add a taper. That's it. You say what is the taper angle, and add a taper. That's it. Oh, this has changed though a little bit. Let me look at this a little bit quicker.
So, but how do you set the level of the taper, where it starts from?
This changed on me here. 1 second. What did they do to me here? There was a, here we go. Oh, I was picking the wrong thing, sorry. You can set a manual collar and a taper. They call it a collar and a taper. Okay? So you can set an angle and a distance, and then an angle and a distance.
Great. Okay.
And then you can have it do conic, square, or ISO. So whatever you want. Again, it depends on the shape. I picked the wrong kind of shape, but basically you set, you know, the angle, 0, how far you want it to go down. They're calling it a collar, and then a length, and then an angle. Okay. So it's all in there. Everything is there. Like I say, I'm going to have a really in-depth class in May, and we'll cover this, you know, with a great detail. But I wanted to show you guys that it's all in there, that you can get in there and you can mess around with it, right? And you can try some things. And if you have some questions, basically I'm the guy. So if you have questions about it, please send me an email. We can also do little you know, web things like this. if you're struggling. Okay?
Okay, thank you.
All right, let's look at this here. This is another really interesting thing that you can do. For example, if you're cutting an outside shape like this, and that's what's really nice about the colors, right? I can set these colors and then just machine them. So I can go in here and I can do automatic, even though it's on the outside. I want to do external features. I want to use the color list. I want to do green, go. And it just does it. It's done. I don't have to pick all that stuff. Really kind of nice. So doing outside features, not a problem. So if you have punch stuff that you like to do, it's really easy. Let me just check something here, because I do a million things and I can't remember half the stuff I do. So even as we're going along here, we can use that Gibbs functionality, right? So I want to select all the tangent faces here. Figures aren't any. I want to do this. Let's set the color. It's that one. Yeah. And let's get rid of these guys. Oh. Let's go in here. Let's do automatic. This time I'm going to use pink. And we'll say OK to that. Created a new operation, because that's how I have it set. So now I have a new operation that is totally separate from this operation. So this one I can add tapers, I can change parameters, I can do all the different things, and it will post separately as well. So this is pretty cool. Again, once you learn some of the basic stuff, it goes really fast. I can show you files all day long on. I thought I had changed these, so I'm sorry about this. There's a couple things here that I think are pretty cool. And I thought I had made this millimeters, but I will make it millimeters, don't worry. Here's another thing I just got from a customer. Now, this isn't the exact file, but it is kind of what they were trying to accomplish. And what I ended up doing here was creating a pattern. Now, I could go through here and pick each one of these and create. Yeah, no, I don't want to do that. It takes too much time. It's just not worth it. So we'll just do vertical wire. And I'm going to go in and we'll do automatic. We'll use our color list. And I'm just going to do that. And I should have my toolpath. Okay. Now, what I want to be able to do is pattern this. So I can go in here and I can say, make a pattern. And how many columns and how many rows? Well, I only want one row, and it updates. And I want as many columns, so whatever I have here, 1, 2, 3, 4, 5, 6. So let's do 6, start with 6. And I think the spacing was, I think it was like 1. This is in imperial, I believe. Yeah, 1 inch. And actually we have 7. And I've just created a pattern, just like that. How easy is that? Now, I could go in, and if I created a start hole location, it would also follow that all the way through. But how easy is that? This customer was creating each one individually. I'm like, yeah, no, you don't want to do that. This just happens to be linearly. You can do it radially if you like. If you have, a round part that you're trying to do a bunch of cuts in. And we should be able to go through, and I'm not going to stop it. I'm just going to let it run. And it will go through and cut each one. So program one part or one section of the part, and then go off and do the rest. Okay? So patterns, very easy to do. Outside cuts, very easy to do. 4-axis stuff, very easy to do. Okay, so far so good? Okay. Last thing, and then we're going to turn this over to Dan, and he's going to talk about 5-axis. But I want to show you something here that you should be, or that you could, in fact, should I do the hard one or the easy one? It doesn't matter. Let's do this one. When I have to show somebody this, like a customer, one of the questions that you're going to get over and over again is, how does this act, or how does it work with Gibbs? Really, how is this going to work? How are we going to be able to do all these things with Gibbs? And it's very simple. Here's a stripper plate part from a die, and let's say I want to do some of the hole stuff. So I'm going to just do a small. We're going to go ahead and we'll run AFR. We'll do this. Okay. So I've created some holes that I need to drill, and I'm going to go in and I'm going to create a tool. I just happen to know the size. Again, with AFR, you can check it, right? But I just happen to know the size. All right. And I'm just going to do a simple tool path. Again, to prove that, this is how I would maybe demo this as well, to say that, you know, this is how we do this. This is how this is going to interact with Gibbs. So if you're doing things and you go, okay, I want to program it from start to finish, this is the way I want to do it. And I'm going to grab all the group like we talked about yesterday, and I'm going to say do it. And, well, that's a little ugly, but that's okay. Let's throw this away for now. Let me go back to this. Sorry, I am a very particular about things that happen, and in a demo situation you could do this. It's okay. It's like, okay, I'm going to sort these out. Forgot to do that. Okay, I'll sort them. Notice now it looks pretty good. We'll say okay to that. I'll just do it, and now I have a clean tool path. So that's good enough for me. And the clearances are wrong, but that's okay. I'm not going to worry about that. So I've created some machining, okay? And I can do all these holes. It doesn't matter. But what I really want to do is this inside here. That's what I need to wire. So imagine that we've done all this work on a part, and now we need to send it over to the wire guy. All I have to do is change this to EDM. Okay. The toolpath stuff goes away. Then I can go in here and I can select what I need to select. I mean, I can make this a color, which do whatever. Let's do manual. And let's start there. Finish, and I'm done. So not only have I machined this in Gibbs to drill all the holes or whatever I'm going to machine, chamfers, whatever the case may be, but I can just take it right into wire, and now I can post it separately. So I can post this as EDM code. I can do everything in one sitting without having to, go out and come back. It's all in the same interface. For those of you who sold the old wire EDM, it would go to a completely different interface and come back, right? We don't have to do that anymore. It's all interactive and it all works really well. Okay? Questions?
Hi, Steve. It's Antonio.
Yes.
Does OptiCAM work only on solids or even on wireframe geometries?
It does work on wireframe geometries. It's not great, and that's still being worked on. It does work. Let me show you what it looks like. It does work though. But it's a bit, still having some issues with it. Because again, the product is designed around solids, right? It's not designed around wireframe. So basically I would come up here, manual feature recognition, manual from 2D data. Okay, so it automatically, it knows that there's no solid here. So it already knows that. So you pick, the problem is it does everything.
Yeah.
Okay, that's part of the issue. So it does everything, which is not really what I want. But again, it does have some downsides. So let's get rid of this one because I don't want to cut the outside. Oh, there's no Control Z either, by the way. This is the downside to it.
Yeah.
Because it's not really designed for this. And you'll also notice too, we have some graphic issues. Again, these are known, but you have this is on the wrong side. So what you have to do is you have to go in here and you have to switch it.
Yeah.
Cut on the reverse side so it's on the inside. That's really what we want to cut. It doesn't know what side to be on. So you physically have to go in and you have to change it.
Of course.
It's being worked on and it will work. I mean, you can perform all the functions. It's just not as clean and nice as the let's see, let's disable. No, let's not do that. Let's just do this. But that's what you have to do. There's no other way at this point in time. You'd have to go in there and do that. Now, all the other things will still work. I mean, you can still open this up and change the technologies and do all those kinds of things. But it's not as clean as we'd like it to be. But again, it's not designed for wireframe. It's designed for
solids.
For solids, yes.
Yeah.
That's what it's designed for. So it will do the job, but yeah, you can see the issues.
Okay, thank you.
Okay.
And which development toolkit are you using for developing posts?
Yeah, that's a really good question. The posts are all done by OptiCAM. We're not doing the posts at all. So if there's a post change that needs to be made, it goes to them. We're not doing the posts. They have a master post, and I'm dealing with them right now, and I have to have a conversation with Israel and about this. But they're the ones who are editing the posts, not us. So most of the things we can do, the posts are pretty good. They're pretty close. The cosmetic issues is what I'm having issues with, to be honest with you. I have a customer right now. Again, after we do the seminar, I'm going into help a customer get up and running. He's going to be waiting for me. And part of the issue is when we post the code, the organization of the code is not exactly the same. So you may have M83, 84, 85 on one line in the old code that he's used to seeing from the old YRDM, and in the new code, it's in individual lines. Now, that might not matter, right? It's all the same. It may not matter. And he said that to me. He goes, that probably won't matter. But I know that there's going to be a customer out there who's going to say, nope, this is the way I have to have it. And that's all there is to it. And I'm struggling with them to get them to understand that. For me, that's important for my customers. Now, will the post work and will the output work and the code looks exactly right? Absolutely. Cosmetically, it doesn't look like the old stuff because in the old stuff, we had control of the posts and we could move stuff around.
Yeah.
So they have been responsive. There was a customer who doesn't use H for offset. They use D, or they didn't use D, they use H. And they actually added it into the software. They added a control that I could actually select it to change it, which was very nice of them. So they are responsive to do some things, but they're reluctant to change their master posts. And we're gonna have to come up with some plan. to make sure that we can get what we want. But overall, when I look at the code and the customers I've been looking at the code is pretty good. It's just cosmetically, it's not in the right order.
Yeah.
Not that it won't work, but it's not what they're used to seeing. And a couple times I've sent it in, a couple times they come back and they said, just because it doesn't look the same doesn't mean it won't work. And that's been their answer to me. And I have to agree with them, but we all know how customers are, right? I mean, we know, right? I mean, we know they're going to demand, hey, this is how it was, this is how I want it. And but they do all the post work. We're not doing any of the post work. There's a couple things you can do. Again, I'm going to do this class in May, and there's a couple things you can do to write some text files for header and footer information, or if a customer wants to see something special at the front of his program, we can make a simple text file and just call it. It's really simple. There are some things we can do, but the core stuff, they're reluctant to change. So we have to have some real conversations with them about posts and cosmetic. Because I said, hey, I want to change it. You know, I want to move these around. Yeah, they're a little bit reluctant because they make money on it. So, you know, that's part of one of the things that they do. So, but so far the code that I've seen out of every post that I've checked, the customers say, yeah, it looks pretty good. Just some cosmetic things. So, but we don't do posts. That's it. So you will send it into, I guess it goes to support right now, which basically we're helping support. So I'll see it anyway. It'll probably come across my desk, and I will send it to the OptiCAM people to get it worked out. At least for now. I'm sure there'll be another avenue, but for now, that's how it goes. So if you have a customer, what I would suggest, I think, if you have a customer with, you know, that is chirping back about a post, just email me and I'll handle it for now. I'm sure there'll be a different avenue somewhere down the road, but for now there's basically one person in the company that knows the software, and that's me. And we're getting other people up to speed and trained. But for now, just send it to me. I'm the one who's closest to it. Most generally, I'm just going to send it to them, and they're going to either say, yeah, we can add some things and change it for you, or no. And then we'll go from there. Okay?
Okay, thank you.
Yeah. Sorry for the long-winded explanation, but posts I know are an issue. But EDM is not like, you know, programming a Mazak, right? Where they have 100 different machines, you know, or 200 different controls. You know, Mitsubishi has multiple controls, but they don't have 100. They have 10 maybe, or 20. You know, they don't have 100. So it makes it a little bit easier to have one post that will cover most of it. And unfortunately, I can't believe the technology crashed like that. I was messing around with it yesterday, and I noticed it, and then it was working, and so I apologize for that. But again, we'll get that sorted out, and not to worry. Okay?
Okay, thank you.
You're welcome. Any more questions about EDM before we turn this over to Dan? I've run a little bit longer than I wanted to, but that's okay. This is a really, really nice product. Okay? If you use it with solids, I'm sure you're going to find some things that don't work or some things you don't like, and that's okay. We have to understand that this is the first generation of it, so it's the first release. I'm sure you're going to find things that, hey, maybe we could do this better, maybe we could do that better. Please let me know, because, again, the Camtech people are very responsive, and they're very, very open to making things change and making it better for everyone. They're very open to that. So please, if you see something that, hey, this doesn't really work the way we think it should, or it could be better here, please let me know, okay? We'll definitely run it down. I'm in front of this every single day of the week, and in contact with them all the time, and working with our guys in California, our developers, making sure that this all gets done, so we have a really cool product.
Steve,
okay? Yes.
What about 5-axis? There are any plans about this? Another rotary axis on the table, yes?
Yeah, at the moment, not that I'm aware of.
Yes, they are planning to do that.
Oh,
That will not be in GibbsCAM 14, so that'll be an additional option that we'll sell once they've completed it. So they're working on that.
okay.
So they've already done it once for they have two EDM products. They've done it once for the other EDM product. They're bringing that over into Opticam. I don't know if it'll be done in time for GibbsCAM 15, but it'll be either a GibbsCAM 15 or GibbsCAM 16 feature, and it'll be a new option, that will require an additional payment.
Yeah. Thanks, Daniel.
Okay.
I figured they were, but I didn't want to speak out of turn.
Okay.
Go ahead.
And my second question, there is also a probing in the wire EDM machines.
Yeah, I'm going to say no to that. We could ask, but I'm going to say no. I mean, I don't know. They might have done it in their other product. We could certainly ask, but I'm going to.
Not as far as I'm aware, but yeah, I mean, we can ask. We can see what they say, but that's not something I've heard come up before. So
we will ask. I'll make a note here, and I will ask Melanie about the probing.
Okay, thank you.
Okay, any other questions? Again, feel free to send me emails if you start using it or have questions about what you can do, what you can't do, part files, whatever. I'd be more than happy to help. Okay, always here to help you. Okay, with that, Dan, I hope you're on the line here somewhere.
I am here.
All right, so I'm going to turn this over to Dan Arrington, our 5-axis expert, and he's going to go through some of the enhancements and some 5-axis stuff for us. And when he's done, Daniel is going to do the work fixture offset stuff. So there you go, Dan. It's all on you, buddy.
All right, appreciate that. I was hoping you would say 5-axis king since you're the macro king, but
okay. So he is the 5-axis queen. Oh. Sorry. All right, Dan. Thanks, buddy. It's all you.
Okay. Just let me get my. Can everybody see that?
Yeah, we can.
Yep, perfectly.
Good.
Okay.
Thank you.
Very good. Very good. Let me move this out of the way here. Okay. I'm going to keep this very brief so that Daniel has plenty of time to talk about work fixture offsets. And like Steve with EDM, I would like to have a 5-axis in-depth training class sometime soon. Nothing on the books yet, but we need to get that done. We need to get you guys more information and try to get you better prepared to answer customer questions and answer your questions also. All right, so first thing we're going to do, we're going to talk about form tools. Okay, everybody can see that. Just want to make sure.
Yep.
Okay. All right, form tools. So this is just a simple round over tool. And in 5-axis, we can now drive those tools with some understanding. Number one, no gouge check. And the reason for that is there's a lot going on. And honestly, if you're using a tool like this, what we're going to do is round over this side here. You're probably gouging just because of the nature of the shape of the tool, the clearances that the tool has, and the shape of the surface that you're trying to create or produce. You're probably gouging, right? Because it would be just about impossible not to at least touch this surface as the tool follows the curve and the shape of the surface that you want to create. Okay, so there's only a handful of strategies that a form tool can run on as well, and that's for a reason. There's, again, a lot going on. So the best one that I've seen is use project curves, because that way you can select an edge that is consistent from start to finish on the form that you're trying to create. And then you just need a drive surface. And if you have an adjacent drive surface, that seems to be a better option, because again, it follows the twist of the shape that we're trying to produce. So basically, project that curve onto this surface, and using tool axis control, we flip the tool up 90 degrees. And that gets it in the correct orientation. But then now we're going to have to do some shifting, because at this point, the very bottom of the tool is going to start here instead of down here where it needs to. So this is where you need the information on the tool, on the actual tool itself. So this radius, and I apologize, these are all in inch. I will convert them to millimeters before we upload them. I was going to do that prior to this, but that's a lot of work. It's not as simple as it sounds. So this is a 1/2 inch radius. So you've got to shift the tool in the tool's X direction to get it from driving the outside of the tool along this edge to driving the shape of the tool okay, sorry, there we go. Basically, we need to shift the tool, and I'll show you the geometry of the tool. We've got to shift the tool in X and Y. And this is, although you'll be able to grab the numbers from the geometry that is drawn for the tool, because you can see here we're 1/2 inch out and 3/4 up from the bottom. So basically, that's why I was trying to roll this around here. There we go. Okay. All right. This is the 2D form of the tool. So from the center line, which is where we drive the tool, we're 1/2 inch. So this will be a 1 inch diameter tool at its max size. And then from the center point, bottom of the tool, up to this point, it's 3/4 of an inch. And what we're trying to do, if you imagine the tool, we're trying to get this point on the tool to follow this curve. So if you have this information, you need this information regardless. Then it's just a matter of shifting to get it to match up to the part. Everything else is the same. So we're cutting one curve here, so retracts works the same. Lead in, lead out works the same. I'm not going to redo these because you guys know some 5-axis calculations take a while. Then we end up with a decent looking surface. But again, let's run back through that one more time because I want to. Okay. As the tool is swinging to follow this radius here, this side of the tool probably isn't gouging, but the upper tool really has no choice but to gouge. Now, sometimes that will be okay, because what you are, depending on the shape of the tool, it may not matter. That material may get removed as we reach the cutting diameter of the form. But again, that's why we don't have the ability to gouge check this. Okay, that's a simple form tool. Again, you need the data from the tool, and you need a good curve and a good surface to orient the tool correctly, to make it follow that form correctly. Any questions on this? Well, first of all, let me say I have yet to have a customer, at least as far as I know. I haven't helped anyone with a 5-axis form tool toolpath. So, feedback. And again, lots of scenarios here that are pretty difficult for me to imagine. So, real world stuff. Questions on that? Nobody? All right. Okay, next thing we want to talk about is barrel tools. We are now able to fully support barrel tools. And in the 5-axis module, this is a tangent barrel. And what's important to know here is how long your flute length is. Because what you're going to see in tool axis control, this used to be the only option for tilted relative to cutting direction. You could give it a side tilt and a lead tilt. Now, this has a second option where you can describe the contact point on the tool. And these are the values for describing that, okay? This is a percentage. So this value is going to range from 0 to 1. 0 being the very bottom of the tool, and 1 being the end of the very top of the cutting portion of the tool. All right, and I'm just gonna run through these so you guys can kind of see. Okay, our option there was 0.4, okay, which is pretty close to halfway up the tool. So given the step over amount and the contact point that you choose on the tool, means that first cut could be rather large because we are cutting with the side of the tool and we are driving it. We are driving it from that distance. And this is good for barrel tools and ball nose end mills. If you have any other type of tool, this option will not be available. So you'll only have the angle choice. Okay, so that's a simple drive it with contact point on the tool. Now what we're doing here is the same thing. We're going to drive it, but this is a starting value and this is an ending value. So these are extremes because I want you guys to see what's going on here. But here we're going to start at 4% up from the bottom of the tool. And when we get to the end of the cut, we want to be halfway up the flute. So it's going to morph the tool path from here to here. And I did extremes so that you guys could see the see what really happens in real time. Okay, so we said, hey, start at the very tip of the tool, more or less. And as we work our way down, the tilt is going to gradually change until when we get to the bottom, we should be halfway up the tool. And again, this isn't how you're going to use it in the real world. Nobody's going to cut a part that looks like that. But the point of this is to show you guys how that function works. And we have the same thing here.
Dan?
Yes.
I got a question.
Okay.
I could imagine that doing it the other way around would be something you would want to achieve because the tool will move away from the wall.
Yes, this is the third operation here is going to do that. Again, like I said, for the operation I just showed you, you wouldn't do that. That's not real world. That was just to show you what's happening. So in the real world, this is probably what you would want to do. You would start at some distance up, and then at the bottom, you would end closer to the point of the tool. And again, just like you're saying, because that's probably what you're going to want to do anyway, because you want the tool to start tilting further and further away as we get or work our way down. And you'll see this. And that's far enough that you can see the difference. Kind of smooth up here as we work our way down. The tilt changes, so the scallop height changes.
Very nice. And another question: can the cutting height be adjusted as well according to the portion of the tool that's actually machining? Because the radius will get smaller, and we saw that that it will leave more material on the surface.
Sure. Not with that option.
Okay.
And the reason for that is is because we at this stage, we aren't looking at scallop height. We're only looking at the angle of, or the contact point of engagement on the drive surface with the tool. Okay. So if we were using a ball nose end mill, okay, then your scallop height would be about the same, as long as you're not past the radius for your starting. Okay, so if you used a 20 millimeter ball and it had 20 millimeters of total flute length, then halfway or 50% up would be where the radius on the ball nose end mill starts on that tool. So from there to here, you would get the same scallop height because it's a consistent shape on the end of the of a ball nose tool. But good question. Any other questions? Okay, so that's kind of two birds with one stone. Barrel tools, yes, we support them, and also covering this new tilt option.
That new tilt option makes it a lot easier than the old one. So that's
absolutely, yes, excellent. yes, absolutely. Yeah, because now it works the way that a barrel tool is intended to work. Whereas before, we were kind of we were doing our best to work around it with the options that we have. But this is how a barrel tool is intended to work. Any questions? Okay, all right, let's move on then. Multi-axis machining. No. Let me get that off the screen. Okay, multi-axis machining. I don't hear a lot about this being used at all, and it really is a great tool for roughing, regardless of the type of machine and the shape of the part. Okay, but roughing, multi-axis machining, roughing, you have two options for how you want the tool path to look. You can do offset, which is a traditional step over, cut as much as you can, step over, cut as much as you can, and adaptive, okay, which is more of a dynamic volume mill type tool path, and they're both really, really, really great options for removing material. But we're going to talk about undercuts here. So we have a new choice here, undercuts. They only work in offset, so if you choose adaptive, you won't get that option. Okay. So if you want to machine undercuts, you have to choose an offset type toolpath. And you have three options here. One, do not machine, which is going to do what it's always done and leave that material behind. Machine, so you can say remove the bulk of the material, but then also go back and get the undercut material. Or you can say, hey, I've already cut out the bulk of the material. I just want you to get the undercuts, okay? And the reason this is good is because this option only works for spherical tools. So ball end mill or lollipop, Those are the only two tools that work, that can cut undercuts. And just a quick run through on multi-axis. The floor surface is what drives the tool in roughing, okay? The tool will always stay normal to your floor surface. So the floor surface accomplishes two things. Number one, it sets boundaries. Number two, it controls the tilt of the tool. Okay, so if you have a flat floor surface, then obviously the tool is always going to stay normal to that. There'll be no tilting. But your floor surface can be a cylinder. It can be any sort of odd shape. And even though this is designed around the idea of a pocket, you don't have to have, you can use this on open shapes, okay? It all has to do with the floor and how your stock is defined for that operation, okay? So what we've done here, this first tool is just a square end end mill, and we are just going to let it get as much material as it can, okay? So all right, so that's as much material as that tool can get without gouging the part, okay? Then we can come back, and this is what's really nice. We can come back with a ball end mill. This could also be a lollipop. And it doesn't have to be the same size as the prior tool. It can be any size as long as it will fit in there to remove the material. And we can say, just get the undercuts. All right. Your depth here, I'm telling it, get all of that in one pass. So go as deep as you can and start removing material. Okay, if we click the advanced here, we have options for what do we want that thing to do. If there's still material left behind after we reach full depth and we've gotten as close as we can to the part surfaces, okay? So basically steps, all right? And here's a good example, okay? A spherical surface, and if we step down, whatever our distance of step down is, there's going to be material left behind in between those steps, okay? So if we turn on intermediate slices, we can tell it how we want it to try to go back and get that material that was left behind by our initial depth cuts, okay? We can tell it a step height. So if your initial step height for the roughing operation was 5 millimeters, okay, then you could say, hey, I know you went 5 millimeters deep, but I want you to back up 1 millimeter, get as much as you can, then back up another millimeter, get as much as you can, okay? So this is a way of telling it how to get the material in between the steps. And we have this option, detect thicker than, because if you give it a really fine step, then you may get a lot of extra tool path because there may be a tiny little bit of material left there, but it's more than what you set for your surface clearances. So it's going to try to get it. So here we give it a little bit of room to ignore some of the smaller remaining material areas. So you set this to 0, and it's going to get as fine as you tell it. So you may get a lot of unnecessary cutting. So here we can say, listen, if you see anything that's under 1 millimeter, again, I'm in inches, so we're kind of jumping back and forth here, but if you see any material that's offset from the drive surface more than 1 millimeter, I want you to cut that. But anything less than that, let it go. And again, you could set this to 0. You could set this to anything, any value, depending on the size and the shape of the part. Okay, this is just a way of getting rid of the some unnecessary cutting. Okay. Part definition is the same. Part surface is essentially your drive surfaces, what the surfaces that you want to follow, and your floor surface. We've already kind of gone over that, and stock allowance for both. Gouge checking, you can define more check surfaces, but this is kind of written to identify from your part surfaces where it needs to cut. Okay, so unless you have a clamp hanging over or some part of the fixture that's in the way, most of the time it's not necessary to have extra check surfaces for this cycle. And sorry, I should have had another stock body. Okay, so here's our undercuts. And remember, we told it go one depth, go all the way down, and then we gave it a finer step over for this operation. But prior to this option, multi-axis roughing wasn't complete, because even if you were able to get the bulk of the material, it couldn't see any surface that the floor surface was pointing toward. So again, something like this. So even after we did this, rough this pocket out with multi-axis, we still had to figure out some other strategy to come in here and get this remaining material. So undercuts, it's really, really, really great addition to multi-axis roughing. Any questions on that?
Dan, you mentioned in the beginning, I have used this probably once or twice.
Yeah.
Once in a project where the part was pretty big in millimeters, it would have been like 250 millimeters, and the tool was like 2 millimeters, very, very small. And the tool pad this one creates for in this case, a Integrex machine with rotary Z-axis and B-axis is great. Absolutely fabulous. The only tool pad that I found in Gibbs that I could use for cutting titanium. So that was all hunky-dory. The problem was the calculation of the toolpath took about 45 minutes.
Yes. That's a drawback.
So that's the drawback, and
that is a drawback.
That makes me reluctant to use it. So
yes.
If there is something we can do about speed, say use this type of computer with 16 cores or 1 core or whatever core that helps that speed, or make ModuleWorks actually do it better, that would be a big help. The solution, the function is good.
I totally feel your pain there. I have asked both ModuleWorks and our side about this, and it's just a very, very big algorithm, and so I will continue to research that, continue to look into that, because you're right. Yes, I have an impeller that I have roughed out using the multi-axis roughing, and yeah, it took same thing. It took in the neighborhood of 30 to 40 minutes to calculate.
Yeah.
But the toolpaths are beautiful. They really are.
Except
especially
when you
the adaptive.
that small mistake, so you have to go back and spend another 45 minutes.
Yeah.
And then, oh shit, I forgot that one. 45 minutes.
Yes.
That's a pain.
Yeah. So when I use this, my step overs, I will set them if it's a decent sized part, I'll set the step overs really wide and loosen up some of the tolerances just so I can see the toolpath to make sure I didn't miss anything. But you're right, that is a huge drawback to this.
Yeah, keep bashing them. I guess that's a good idea.
Yes. Yeah. But in adaptive, which is really nice, and I'll include some examples of that in the files that we share for this training. But in adaptive, you have radial chip thinning control, so you can change the feed. The feed rate will constantly, change based on the engagement of the tool, which is great. So imagine a full 5-axis volume mill type toolpath. It's beautiful. Yeah, but it takes a long time to calculate. Any other questions? Okay. All right. Very good. One last thing. 5-axis material only. It's essentially kind of self-explanatory. So let's see that one. Okay. I'm just going to load this operation first. Okay. So very simple. Project curves or parallel to curves. Sorry. Selected a curve, drive surface, and in the roughing tab, set up multi-passes and some large number of passes, okay? And the reason for this is so you can see what will happen if you don't have stock defined, okay? So multi-passes, it's going to do exactly what you tell it to do, okay? But that's without material only checked. We have exact same parameters. There we go. But material only checked. And again, I'm not going to waste time redoing these operations because we need to get through this. But material only is now working. So there's no stock defined within this process. Material only now goes out and grabs the stock, the state of the stock at all the way down to the last operation, and then automatically plugs that into your process when you check material only. And if it's a roughing toolpath, the toolpath will be trimmed to the material. Just a few notes or cautions here. This in ModuleWorks, this is our page. This is a page that we create, and that's where the material only checkbox is. Okay. However, there are options such as swarf machining, where you don't define stock. Okay. And it should not matter if this material only is checked or not. However, I did the math one time. So just for this one, no matter what it is, parallel cuts, parallel or curve, whatever, once you get below this, once you've defined your curves and your drive surfaces, so from here all the way through all the tabs till you get to the end and click the Do It button, there are something like 17,000 different combinations that you could have. And that doesn't even, I'm going to do it again because I'm thinking now that it was 170,000. But either way, just understand that there are a lot of combinations and choices here. So it's possible that this could maybe interrupt one of those. And if it does, just let us know, and we'll do what we can to work around that so it doesn't create an error. Oh, I also want to say, sorry, one more thing. Okay, material only, this is great because now you don't have to save all those facet bodies as you go along and then plug them into each process, but you still can define stock some other way. And the reason for that is because for some of these toolpaths, or for some of these operations, the toolpath that you want, it may take the stock looking different in order to get the toolpath that you want. So you can still get creative. You're not locked into material only. You can go either way. Questions? All right. I guess I'm done then.
All right. Well, thanks, Dan.
Yeah, thank you. Thanks, guys, for listening to me talk. And you know how to get in touch with me if you have questions. And again, like I said, I want to set up a 5-axis class, online soon. So when I get the details of that set up, I'll let you guys know.
Perfect. Thank you.
Thank you, Dan.
All right. Now, how do I stop sharing?
Yeah, you got to stop sharing. All right. So we are a little bit long, but, I think we have one more thing to cover. We're going to cover it with Daniel is going to talk to us about work fixture offsets. Right, Daniel?
That's right.
Are you going to show a screen, or do I need to do something for you? Okay.
No, I'll do it.
All right. So Daniel's going to
figure out how.
Yeah, the share screen button.
I think you got it. All right.
All right. So Daniel is going to explain to us this work fixture offset, except you got a black stripe on your screen there, Daniel, but I'm not sure what that is.
Black stripe.
Yeah, I don't know if anybody else can see that, but I see a.
Where? What size is it?
It's at the top.
I see it also. It's right below the number 1 tool tile, and it goes basically all the way across. Yep.
Oh, that's interesting. Is that better?
No.
Stop sharing and share again, Dan.
Yep.
Stop sharing and share again. Yeah.
Same thing?
Same
or
thing.
Is it better?
Yeah. No, same.
Right. We are going to switch sharing modes then. We'll try this.
I will say I haven't had.
Have my whole desktop.
Yeah, that worked better.
Yes.
Okay.
Yep.
Yeah, I've seen that before.
Yeah.
I've seen that before with Teams. So, all right, Daniel, it's all you, buddy. Have at it.
All right. So, my goal here is to answer kind of 3 big questions about the work fixture offset GUI and the new work fixture offset system in version 14. The first one is just what is it? We get that question occasionally. Second is how do I use it? And the third question is why did we do it? And so I'm going to kind of address all 3 of those. We're going to start with what is it? It's a way to assign CNC work fixture offsets to your part program on a per operation basis. So in the past, the CS list had a column for work fixture offset, and you set a number there, and then all the operations that were using that CS would pick up that work fixture offset. There are a few problems with this, and I'll get into some of the details as we go along. But first, I just want to answer the really general question, what is it? And then get into a little bit of how do I use it? How does it work? So if we look at the post processor window, there is a work fixtures tab, and this is going to have different contents depending on what kind of post you have loaded. So I have an old post loaded here. This is a pre-version 12 post. That is the point at which we added support for the work fixture offset allocation engine in GibbsCAM, but we didn't yet have a UI for it. So it was just kind of trying to emulate the old behavior. So if you have an old post loaded, you'll see this. It works exactly the same as the WFO column in the CS. It's just in a less convenient location. Sorry about that. So, this should not be a surprise. This all works the same way as what you're used to. Where we get the change is if we load a newer post processor. So if we grab, let's say, this post processor, now we have an interface here where we can control exactly which work fixtures are being allocated to which operations. And I'm going to go through this part in some detail in a minute. When we get towards the, why did we do it? This part is kind of designed to answer that question. So once you have the new post loaded, you can see which control WFO is being assigned to which operation, and you can change it. It'll also display some indicators about what kind of WFO and what kind of shift is being used for each operation. So that's this column to the left here. That'll have different icons depending on what's going on. I'll go through all the details of that as well. So that might be a part station WFO, like a G54, or part instance WFO if you're using multi-part. It might be a native local WFO, in other words, one that's actually using the origin from the op CS. Or it might be a borrowed WFO where we're using an origin from a different operation or something like that, all of which is now possible but was not previously. It could even be a WFO for a CS that's at a different rotation, which might be useful if you have a control that has dynamic WFOs, or it might be kind of a last act of desperation if your control just doesn't have enough WFOs. You might decide that your setup is close enough for some features on the part to borrow WFOs from a different orientation. When a WFO is being shared with a different CS, you can choose to either output the toolpath that shifted into that CS. So all the numbers in the toolpath will change, or you can output it with a local origin, like a G92 shift or something like that. And that's what the use local shifts checkbox is for. So these other checkboxes up here control various options about how the WFOs work. One WFO per part basically will take a B style or C style post where you have a work fixture offset per operation and kind of reduce it to having a single work fixture offset like a D style post would. So I can check that, and you can see I'm now getting G54 for everybody. And then combine identical WFOs, I'll get into in a minute. We can also see all of the details about these WFOs. So we can see not only where our origins are expected to be by operation and what the orientations are there, but we could also see them by WFO. So we could sort, we can see that we have operations that are sharing work fixture offsets and what those work fixture offsets are. So you get a nice table of what the offsets are expected to be on the control. Previously, the only way to get that information would have been after post-processing. You could have it output in the post and read it there. This way, you can see it as you're programming the part and kind of understand what's going on with what will be going on with the offsets on your machine. Okay, so let's take a look at this part briefly before I kind of get into details here. We've got every machinist's favorite test part here. It's a cube that has holes drilled in it. There are 8 holes in the top. Each hole has its own operation, just to try to keep things simple. So hole 1 here is has a CS at its own origin, as does hole 2. So this pair of holes each has its own CS. Holes 3 and 4 actually share a CS. So both of these holes are done in the same CS. And then hole 5 and 6 are using different CSs. So you can see my CS on the left here has changed between hole 5 and hole 6. And by the way, I have Activate Machining CSs turned on, new GibbsCAM 14 feature, which is why you can see the active CS shift as I double-click operations. Happens to be really nice for this demo. So these 2 holes are using different CSs, but those CSs have a common origin, and that's going to become important later on also. Then holes 7 and 8 each have their own CSs. They're really just there to kind of inflate my CS count so that I can trigger some other behavior later on in the work fixture offset dialog. Then holes 9, 10, and 11 are on this side of the part. 9 and 10 are sharing a CS. 11 is in a different CS. The interesting thing about these holes is that hole 9 is machined on the left side of the machine, and hole 10 is actually using a different solution for the same CS on the right side of the machine. And hole 11 is using hole 9's solution, not hole 10's solution, even though it has its own CS, where hole 10 is sharing hole 9's CS. It's clear as mud? Are you all still there?
More like strange and wonderful.
Okay.
Yeah, clear as mud.
Surely it's there, still there. Yep.
So if we just look at what this part is doing in part space, we can see it's drilling holes. Okay, there's nothing really fancy going on here. If we look at machine space, then the top isn't surprising. This is the surprising part. We're using alternate solutions for these holes. Okay, so that'll become important as we look at what's happening on this part and what the old system would have done, because what it would have done is crashed your machine, and that's bad. We don't like that. So part of the purpose of the new system is to avoid some of these cases where we can have a single CS that really needs to be several different WFOs on the machine. We can now detect those cases and allocate them separate WFOs so that your part will actually cut correctly. Let's talk about the advantage here. So that's the rescoping WFOs to be assigned to operations instead of CSs gives us a couple things. One is it gives a lot of flexibility and power to the user. So you can now assign CSs, assign work fixtures to operations regardless of what CS they're programmed in. So you can combine CSs that are programmed in operations that are programmed in different CSs can share a WFO, or operations that are programmed in the same CS can be split into several WFOs. And I'll talk about that in more detail and show you how to do that. And it also avoids some of these more serious problems. In this case, I'm just using solution control to trigger some of these problems. But you could also, if you had a 6-axis machine, repositioning the 6th axis on a 6-axis mill will introduce some of these same problems where you'll have the same CS. We'll even choose the same solution for the 4th and 5th axis, but the points in that coordinate system are not going to line up with the work fixture offset that was allocated in a previous operation at a different 6th axis angle. You can also run into this on a 4-axis part if you're machining in the same CS, but you're using rotations. So if you have one operation that's starting at 90 degrees, a different operation that's starting at 180 degrees, those are different positions on the machine, potentially, if you're off-center. Okay? So this system handles all of that, and it really does a good job of providing feedback to the user. Now, I will make a note here that I am not actually using GibbsCAM 14 for this demo. We are working on this feature still, and that's been kind of a long process as we're incorporating customer feedback from GibbsCAM 14. So if you're following along at home with your copy of GibbsCAM, it might behave a little bit differently right now. You will see some bugs in what I'm showing that you won't see, and you will also get some bugs that you won't see in my demo. We'll get the new bugs that we've introduced in this version will get resolved before we promote it to GibbsCAM 14, but this will be kind of the things that you see here will be coming in GibbsCAM 14 as well. Hopefully that wasn't more confusing. Let's talk about how different posts deal with this. So this is a Fanuc post. You can see we're using Fanuc work fixtures. You saw what an old post does. You can see, if I grab a Heidenhain post, it's a very different work fixture format, but it's the same general idea. You can choose which work fixture you're assigning to. Or if I have a machine that has a limited number of work fixtures, so in this case, an older Fanuc control, you can see that we've actually chosen to go back to G54 for this. And you might ask, why is that? Why are we using G54 for all of these operations? And what do all these funny icons mean over here in the left column? Let's talk about that. Okay, so the work fixtures have all gone back to G54 because we don't have enough. Okay, and that's why I have holes 7 and 8 that are just kind of sitting out here, and there's nothing special about them. The reason was to make so that there would be too many work fixtures for this post. And because there were too many work fixtures, the post has specified a fallback behavior. In this case, it has chosen to fall back to D style. So it couldn't give each operation its own. It only has G54 through G60, and there are 11 operations here. So it has 7 work fixtures. It has 11 operations. It's not going to work even with the ones that are being combined. So it's chosen to go back to G54. Now we can override this behavior. So in this case, for example, this old Fanuc control probably does not support dynamic WFOs, and I can see by looking at this icon, these 3 WFOs are all being performed at a different orientation. So I probably don't want to use G54 for those 3 WFOs. That would mean I'd have to get my setup data exactly right. So my part offsets would have to be exactly right. In GibbsCAM, they'd have to match exactly what I see on the machine. Now I could do that if that's what I wanted to do, but I could also just assign these different work fixtures. So I could assign this one to, say, G55, which it hasn't taken right now. But you can see that I now have the little green dot there. That means it was being manually assigned. This is one of the bugs that will get fixed. If I look at the by WFO mode, you can see this operation is actually gone. So it did pick up that change. It's just not showing it in this list. So I could assign this one. This is at a different orientation again, so I could put it on G56, and then I could put this one back on G55 with op9. Okay, and you can see that something interesting happened there when I did that last one, which is I'm now only using 7 work fixtures. Okay, and so the system has detected that I can now go back to being in C style, I don't need the D-style fallback anymore because I've chosen to assign hole 9 and hole 11 to the same work fixture, even though they were different CSs. All right. Are there any questions yet? All right. I will continue then. Now we can still see these icons here. Again, this one on the right means that we're at a different orientation than was specified by the selected work fixture. This is wrong in these two cases. This one means that we've picked one by hand. That's correct. We have picked these 3 by hand. And in fact, if we picked another one, we could say, I want hole 8 to be done in hole 7's work fixture. We can see that this one has now been selected by hand. It has been overridden by the user. And then this one up here, the little origin marker, means that this is at a different origin. So we have moved hole 8 from being in a CS that has this origin to being in a work fixture that has this origin. So that means that this hole is going to be shifted. Now that might mean you get a different Y value output in the G code. That probably is what it will mean for this particular post. But if I check this box, what that'll mean is it'll actually do a G92 for this operation, and we'll get a local shift, and we'll still output Y0. We'll be in this WFO, but with a local shift applied. Okay. What does that mean? Okay. And what does this box do? I forgot to talk about combine identical WFOs. Okay, so what combine identical WFOs does, let's open one that's not going to be limited. So we'll grab this Haas post. There are plenty of WFOs in this post. We'll reset everything. So this will be all default operations. So you can see we're using G55 through G59 and also G110 through G113. You can notice here that operations 3 and 4 that are sharing a CS are also sharing a work fixture offset, and that operations 5 and 6 that are not sharing a CS are sharing a work fixture offset, and that's because of combined identical WFOs. So both of these CSs, the whole 5 CS and the whole 6 CS, have a common origin. We can detect that case, and if you have this box checked, we'll output a single work fixture offset for that origin. If you don't like that behavior, you turn it off, and you can see we've allocated a separate CS for hole 8 now. We've allocated a separate WFO for operation 7. I got a lot wrong in that sentence. So you have control over that. You can also merge them manually. So for example, operations 3 and 4 are using the same CS, using the same WFO. Operations 5 and 6 are using different CSs with the same origin. I could set them manually. So operation 6, I can set to G58, for example, here. And that's just fine. It'll recalculate the rest of them, and we will be using less work fixtures on the machine for this particular part. We can also do it the other way around. So if I put that one back, and then I say, operations 3 and 4, I've programmed in the same CS, but I don't actually want them sharing a work fixture. Maybe I'm probing one of these operations, and with that probing operation, I'm changing the contents of the work fixture register on the machine. So even though I've programmed them in the same CS, I've identified a process problem that I'm going to be correcting dynamically during runtime with probing. That means that I need a separate CS for this. Rather than reprocessing the operation, which, if it's, say, a multi-axis roughing 5-axis operation is going to take 45 minutes, as Michael said, I can just shift it into a different WFO. So I know that, for instance, G120 is free. That shouldn't have happened. This one should have stayed in G57. I can set it back manually. But I can assign these to different work fixture offsets. So now operation 3 is in a different work fixture offset than operation 4, which means if I have to move them separately on the control, I can do that. Okay, so kind of to sum up what our advantages are here. If you have a B style or C style post but want to output to a single WFO, you can just check the box. So, hey, this is a C style post, but I really want one WFO per part in this case. Just check the box, you'll get D style output. That means you don't have to experiment with as many posts. You don't have to send as many posts to your customer. You can just tell them if that's the style of output you like, check the box. Programmed ops in different CSs that you want to output in a single WFO, you can just reassign. If you've programmed ops in more CSs than your machine has WFOs, the system will automatically fall back to local shifts. And if you don't like the particular fallback we're using, or there are some ops that are really important to have in different WFOs, you can reassign them manually. And if you've programmed ops in a single CS, but at different rotations, they'll get different WFOs by default. And if you have programmed ops in a single CS, but you want to shift them independently on the control, you can assign them to different WFOs. If you're dealing with multi-part, you get some additional advantages, and there's actually a separate icon. So this blue icon means this is the part instance, the G54 in this case for this post processor. We also have another icon that we'll fill in here if we're on an instance CS for a multi-part scenario, for a mill multi-part scenario. And in that case, you might run out of work fixtures relatively quickly, and you may want to assign certain operations to share work fixture offsets between parts. For example, if you're doing face milling, you may not care that your X and Y positions are not exactly right for each part. You'll just cut some air on each one, and that'll account for the variation, which means you can go through and set each of your face milling operations to share a work fixture offset, while the more important operations are all getting their own work fixture offsets, and your parts will all come out right. And then the last big advantage of this is that you can actually see what's happening. So you can see, hey, all of my work fixtures are set to G54. I'm getting all origin output here. It's no longer invisible. It's no longer up to your post processor. It's now in front of you, it's controllable by you, and it's visible to you. Okay? So, any questions on work fixtures?
Yes, Daniel.
Yes.
There is an option. The CS list that I see here, it's used by the operations. Okay, can I assign an op to a CS that it's not in use in operation?
You mean as far as?
I would like to create a new CS, okay, and not use it in the operation, but I would like to assign the operation to that CS.
So if it's in use by a different operation, then yes, it will already have a work fixture operation. If assigned, if it is in use by a part or a part instance, it is also going to get a work fixture assigned. So like in this case, I can always choose to assign something back to G54. Okay. And it knows that that's my XY plane, that's this origin is my G54. Now in this case, you can see I have here also CS2, the YZ plane, that shares an origin. If it didn't, but I didn't have any operations programmed in it, I couldn't use that offset as a work fixture offset origin, just because of the way the UI is set up. So it doesn't have a work fixture number assigned to it, which means that I don't have a way to select it.
Okay.
If you have a need for that, we can talk about how we might be able to do that.
Yes, I will send you an email about that. Okay.
Yeah, so this system certainly has the ability to do that internally. We can use any origin, anywhere, but we've chosen to expose just the ones that are either in use by an operation, in use by a part, or in use by a part instance.
Okay, VMM can also use an CS, and this is something that I can solve with the VMM, for example?
The VMM cannot reassign them because this is really a user action. So the user is choosing the work fixtures. The VMM is not choosing the work fixtures.
Okay.
Utility ops that are using CSs will get their own work fixtures. So.
Okay, I will send you an example and the need by email.
Okay.
Thank you.
Daniel, a lot of complaints about the V4s is for a post that is using warplanes instead of V4s.
Okay.
For these types of posts, basically you are using a single V4 for the all operation and all CSS.
Right.
How can it help? Yeah, sure, but not G54. How can the user change all V4s for all operations to something different than a part CS or part V4?
So you can't change it to something other than the part origin. You can renumber the part origin. That is not something that's been added even in this build yet, but we are going to add that here. So if you want to change the number, which I think is what you're getting at, we've had a lot of customers ask for that.
Yeah.
Like G54 is in use by a different part or something like that. I want to shift this one to a different number. It's okay that it's the part origin, but I want to use a different number for it. You will have that ability here.
Okay, that's what I'm asking for. Thank you.
I think that was one of the very first things that we heard from a customer that really hit us as like, oh wow, that was a really big oversight in the system. The fact that we will always use that first work fixture will create conflicts on the machine. Okay, any other questions? All right. How about any questions that stuck around from yesterday? I know I missed the last hour or so. So if you happen to think of questions having to do with the stuff Andy talked about or any of the stuff Steve talked about on previous days, I'm here. I'm listening. I can answer questions.
The toolbox thing with the offset positions was one thing that I know that we talked about. But we can talk about that offline. I think we've already had a discussion once, but we need to talk about it because it's becoming a bigger issue. That one I know for sure. So, and your probing idea didn't really work because of the same reason. With the Star Pro, we talked about maybe using intermediate tooling, but because we can't describe 4 positions on an ATC, it doesn't work.
You should be able to have 4 attachment points.
Nope, it doesn't work. Anyway, we can talk about that. We'll have another discussion because
we should talk about that.
Yeah, because it's coming up more and more. So that was one of the things for sure that we need to discuss. Okay, anybody else?
Maybe I have something for Daniel that Shai was actually, and I have asked Daniel to send me some answers on it already, and he did. But maybe while we have Shai on it, and maybe others too, Daniel, do you remember what I had asked you and you had written me back about? Can we do U-axis directly on the machine instead of on a U-axis head?
Yes.
Can you elaborate on that a little bit while we have people on?
So U-axis turning is enabled kinematically. So as long as the axes are available, we don't really care where they come from. So you can add them in an intermediate tooling, and I think that's what a lot of our examples have done because both the Comet and the DeAndrea heads work that way. But if you have like a Cogstil head that's permanently attached to the machine, or if you have a Trevison machine that has the U-axis built in, it's perfectly all right to put those in the MDD, and we'll pick up the U-axis from there and do U-axis turning just like we would if it was intermediate tooling.
And wasn't there a question about US?
I have one question about the Trevison machines. Have you worked anything with Trevison with U-axis? We have a case in Sweden with Trevison machine.
We've talked to them some. They have not been the most helpful. But if you talk to Chris Hayes, he might have some more information on that. He was kind of the contact point for them.
Okay. Thank you.
It's definitely a machine that was a part of the targeted support for this release. So I don't know whether we have all the programming details for them, but we definitely intend to support them. And if you run into problems, we will certainly be happy to help.
Thank you.
Thanks, Daniel.
Wasn't there a question about U-axis turning, doing B-axis?
That was probably Frank, huh?
Yes, correct. To remind you.
Yes. So no, we can't do that today.
Okay.
So if the entire head would rotate, we can't do it. If the tool rotates within the head, we can do it.
Okay. So axis rotates on the tail.
Right. So that is not really something we can do today. And the reason is, so I'll talk a little bit about this. So our turning, this is actually a kind of a fundamental problem with turning. Turning assumes that we have a constant center of rotation. And when we tilt the B-axis, we're actually changing the axis of rotation. And so none of our turning toolpath works. So that's the reason that you can't do that specific thing. If you kept the axis of rotation constant, you could tilt the tool within the axis of rotation.
Mm-hmm.
But that is not what your case was doing, certainly.
Okay.
Good explanation. That was just want to be sure that we cover the bases.
Oh, that's a good answer actually. Well, good to know. Let's say like this. Not a good answer, but a good to know.
Well,
Well, and I mean that identified a problem with the way we think about turning. With elliptical contouring, for example, we don't have that limitation, whereas with ordinary turning we do. And so the question has kind of come up internally about how should we be handling these things that are kind of turning adjacent but are not literally turning. And so we will continue looking at that for the future, because those are certainly cases that we want to support. There are certainly cases that people have come up with, machine manufacturers and tool manufacturers and so on have come up with some clever ways to use some of these kinematics that we don't support yet. Despite being probably better at handling machine kinematics than any other system on the market, we don't have really total flexibility yet. And so continuing to identify the places where we fall short of that is important and will help us maintain leadership.
Okay, thanks.
Okay, perfect. Thank you, Daniel. Anything else?
Yes, it's me again.
Great.
On Monday, I sent a part to Steve to show it here because I got a question concerning 3D material only or material, the new option, because I came across a case at a customer where I wanted to extend the toolpath by entry-exit moves, and it didn't work when round corners wasn't active, but as soon as I activated it, it worked. So I found this kind of strange and just wanted to know if this is a kind of intended behavior, or at least a behavior you can explain, or if it is not intended at all.
So if you are using Tool Edge, it is possible for lead in and lead out moves to be trimmed out if their contact point would have been trimmed out by material.
Okay.
So that should be a problem specific to Tool Edge, and if you're in Tool Center, you should still get the extension that you asked for. I think it's technically a bug, but it's something that we've had to live with for a long time, and it's kind of intrinsic to the way tool edge works, in that we have to do this trimming when we encounter material with the edge of the tool, and we have to do it late enough that the entries and exits are already applied.
Okay.
So using round corners in that case probably just shifted the contact point enough that it was clear of whatever intersection had been trimmed.
Okay, and then it applied the entry exit move.
Yeah.
So if I correct me please if I'm wrong, but if I use the tool center option and calculate the toolpath with it, and then turn on the tool edge option, I found that it'll change the toolpath immediately, so I do not have to recalculate it. So I could kind of work around it by doing this trick.
I don't think so. I think when it did that kind of immediate recalculation, it would immediately trim it out.
Yes, I see.
So
I see.
It's happening quite late. If it's the problem that I think it is. Now it's possible that you've run into some other bug. I'm not going to assert that GibbsCAM is bug free, but that seems most likely to me, based on the way you described the problem, is that it is likely to be a tool edge problem where the entry is being trimmed because it's intersecting at a within the part or within the offset.
Maybe I can show the part.
Well, I have it up. I have it up here on the screen.
Okay.
Right.
So Steve,
I need control of the system back.
There we go. That do it?
Let's see. Give me 1 second here. Okay, so here's the part.
Yeah, that's it, and it's operation 8. If you have a look at the toolpath, currently it's without the rounded corner options, and you see the toolpath will stop immediately as soon as the edge is reached, and by this the tool will speed along. You can see rapid along the material that's already machined, and it wouldn't be too nice to have this on a machine actually. So I wanted to extend the toolpath a little bit. And if you open the process, please, you can see as soon as you activate the round corners option and redo the process, the entry exit line of 10 millimeters will be applied actually. So we can avoid the rapid movement along the already turned material there.
That's interesting. It's on the inside there. So I don't know why round corners is changing that.
Well, we can give this to you. You can have a look, or we can pass it off to someone.
What is on the open side tabs? What do you have set there? Because that's probably what I would have used to control this. Contour doesn't have that option. Okay.
But minimum cut is, zero should cut everything. Okay, yeah, I think I tried that already.
Okay. We can certainly look at
only
that.
use stock. Cancel the use stock, maybe.
Yeah, but that's what I wanted. That's exactly what I wanted. I wanted it to stop where the material is not, but I didn't want it to wrap it along the already machined face.
Okay.
Because if you turn off material only, it'll also move along the radius.
Right.
This is what I wanted to avoid.
Well, we'll get this assigned and we'll get it turned in give it to Daniel or whoever, and they can dig into it and get you an answer.
Okay,
Daniel,
yeah.
we saw in the early days, we saw some strange behavior in pocketing, etc., when round corners wasn't checked because customers kept feeling that they need to eliminate some moves, so they kept on checking that box.
Yep.
And then suddenly we ended up with a pocketing that didn't clean out the pocket and situations like that in the early years. So it seemed to me, and you can of course comment and correct me, it seemed to me that the pocketing, etc., was designed to use round corners as a standard behavior. Everything was written like that. And the aftermath was creating that sharp edge toolpath, which created some new problems.
That's definitely true. So the round corners is kind of the way that we expected all of this toolpath to be used. So that Bill expected it to be used in the 1980s, so the option to omit the round corners is definitely not really built into the algorithm. It's something that's been added on.
Okay.
But it shouldn't be changing this behavior, I don't think.
Okay, well we'll get this packaged up and we'll get it sent off to them.
Okay.
Okay.
Thank you very much.
Okay, so that's going to be the end. Again, we ran a bit long today, but that's okay. We're here to help you guys, so let us know what you need. And with that, I'll say goodbye.